Hello everyone and welcome. In the last episode, we broke down how language models actually work. Starting from a simple prompt, we saw how it turns into a number through tokenization, how the model generated text one token at a time, and how parameters like temperature shape the creativity of the output. If you missed that one, I would recommend watching that one first. But here is the real question. If a language model is only predicting one token at a time, then how does it actually behave like an assistant? How does it understand your question, respond naturally, and carry a conversation? The reason is that a language model on its own doesn't know it is in a conversation. It just sees the text and tries to continue it. If you type a question, it might just keep writing more questions because simply it has no idea that you're waiting for an answer. That is where chat templates come into play. A chat template is a structured wrapper around your message that tells the models who is speaking, what was said, and when is the model turn to respond. Think of it like adding a stage direction to a script. You define the role, whether that's helpful assistant, a legal advisor, or coding tutor, and the model knows exactly how to show up. And that is exactly what we are going to explore today. I will show you what chat template looks like behind the scene and how you could set it up in a few lines of code. With that, let's get into it. Welcome everyone to our second hands-on lab. In this session, we are going to learn how chat templates turn language models into interactive assistants instead of just text generators. In the previous lab, as you can see here, we use raw text as an input, and we see that how model acts as a text generators by predicting one token at a time. But to enable real interaction as an assistant, we need an extra step. To do so, we need to structure the input by assigning role like system, users, and assistant, and then pass it through a chat template so model learn who is speaking, what is the context, and when it should respond. And that's exactly what we are going to cover today. We will start the lab by investigating about the limitation of a raw text string as a prompt. Then we will learn what chat template is in practice and how we could define and assign a role to it, such as a system, user, and assistant. And then we will learn about the apply chat template function that we could use to format your message that is proper for your models. And so we could feed it to the models. And then we will learn about how we could use chat template for multi-turn conversation. And finally, we will investigate about the behavior of models by changing a persona using system prompt. We should also consider that the chat template here that I'm going to speak about is specific for llama models. Maybe using different models, you need to use a different chat template. So for your reference, I also provide this website so you could maybe have a look at that and see that if it is fit with your need or not. The first thing that we need to do, we need to check our environment, and we can see that we have an access to Torch environment, to Torch platform, and we have accessibility to CUDA, and our GPU model that we are going to use is a Tesla T4, and we have access to VRAM of around 16 gigabyte. I've already installed Onslaught here because it takes some time, but full explanation about this part is already provided in Lab 1. Similar to this part, I have already run that because it takes some time. Again, I explained all these parameters in Lab 1, and for your reference, I highly encourage you to review that. So the only difference that we have compared to the previous one is that we increase the context window to 512 because it makes your context longer. The data type and then the loading models, they all remain the same, and I provide all explanation in the previous video. So we have, with this, we have our model and tokenizer, which we could also start to work with. So now let's run that models, and this is exactly the same as the previous video. So I run that models based on a raw prompt. There is no chat template here, and you can see that explain in one sentence why small language models matters. We convert it to token IDs, and I repeat this process for 3 times to show you the behavior of the model. What you could see here, you could see that model it tried to do its best to predict the next token until it reached to the maximum number of tokens that we defined here, which is 16 tokens. And we also activate this do sampling true, so it means that every time once we run the model, create different samplings, you can see that all these 3 sentences are different. The thing which is interesting here is that always the sentences start with the raw prompt. You can see that explain in one sentence why language models matters, and every time you could see that the model is responding in a different way, right? This is basically, if you want to, it does not understand its role. It doesn't know if it is AI researcher. You expect him to be as a financial advisor. The role and persona is not there. So we would have a kind of limitations to, we have less control on the output that the model can generate. So what we need to do here, we need to define a chat template. With the chat template, what we can do, we can define the role for models, and there are 3 different roles here. We have a system, we have a role as a system, which indicate as a developer. It specifically means models that we set the persona, rules, and behavior that we could see that I will explain later on about them. Then we will have a user, which is you, as the person who asks a question and send the prompt to the model. And assistant would be again the model that come with a kind of a reply. So in practice, how it look like, we need to define it as a list of a dictionary. As you can see here, we have a role, and then the role would be here system, and the content would be we expect from the model to be a helpful assistant. So we put the content here, and then here we have a role, and you as a user, the information that you would like to ask from a model would be explained in one sentence why small language models matters. So this is it. And assistant is not here because the assistant would be the output that we would want the model to generate, right? We only introduce the assistant once we want to fine-tune our model, which I will cover in the next video. And after that, we need to apply a chat template such that the model is able to bring it into the string format that is usable for input for the models that need to be input. So we need to run it here to see it in practice how it look like. We will go over all detail here, so you could see that we have a message that as it has been explained here, and then after that what we have here is that format text. It would be tokenized apply chat template. We have 3 different parameters that we need to consider. The message would be the list of dictionary. Tokenizer, as opposed of a previous tutorial, we need to keep it false because the output need to be in the format of a string. So we do not want that the tokenization would happen. And add generated prompt, it just append the assistant header, so that would be a signal to the model to understand that now it is your turn to speak. So how the output would look like, the llama, it just see these kind of a special token that says that, well, begin of a text. As you can see, everything is happening by applying this simple function here. It just sends a signal to the model that the text is coming. Then we will have a special character like start header ID and end header ID would be, in between would be here would be system, and here would be, for example, user. And then we need to insert the content here. You're a helpful assistant, and at the end that would be a special character say that this is end of token IDs. So it shows that, well, the information that we give it to the model, it has been so you are a helpful assistant. So you might wonder, okay, what is that? This is, you can simply ignore that because this is like a part of the prompt that it says the cutting knowledge of the model that gets trained for Llama 3.2 would be this date, and the date that I'm using that is in 19 March 2026. And for user, again, we are doing the same thing. So we have a start header, and then we have end header, and here we just write, explain in one sentence why language models matters. And at the end, we just say that now the model, it's your turn. It's a start sentence, assistant, and end header, so that you are assistant, and we are expecting you to generate the output. So, and that is it. So we in the next step, what I would like to do, to write a pipeline that you would be able to create that end to end. So the first thing that this function of a chat is doing, we will give it as an output, as an input message. We define the temperature, top K and top P, and maximum number of a token that we expect that model generate. However, all these parameters has been already explained in a previous video that I highly recommend to look at that. So the first thing that we do, we apply chat template that I explained before. Then we conduct a tokenization. Then we will see that, okay, we do not want our prompt to be repeated over and over. And we generate the output based on the parameter that we have been already set that up. As I explained, this part has been explained previously in a previous video. Now let's run that. We could see that as input we give it like a message explaining one sentence why a small language model matters, and we expect that the model act as a helpful assistant. So let's run that and see what output would look like. So a system would say that a small model, such as those used in chatbot or virtual assistant, can be significant impact on our user experience, blah, blah, blah. So this is pretty much about how we are able to act, to work with the models. However, using a chat template, we would be able to control the way that we are able to get our output. So we could define the persona for models by changing the system. So we just assume that the first persona would be your AI science researcher, and the second persona could be your financial advisor, and the third one we do not define any role. So let's run that, and we expect that explain everything in one sentence, no more than that, because I didn't want that to make it longer. So you see that it generates so as an AI researcher, it uses language translation software matters because efficiency, process, and matters, enabling applications, blah blah blah. As a person who is like financial advisor, let's see what has been generated. Just try to explain it, to do it best, to explain the thing in more in a simpler way, maybe. But it's not 100%, I would say, it's guaranteed. We need to play it a little bit around that and see. But as you can see here, once we do not define anything, it just try to be less predictable. It gives you an answer, but you can see that it gets longer and more difficult with to get the kind of prediction on top of that. Maybe let's do that. Let's change it in a different way, into bullet points, and then we do it bullet points, and then here we can maybe use it into numeric point. Let's see what would be the output here, because now we would like that the model created based on the bullet point for the first one, and the financial advisor, yes, you can see that we are able to, for the first one, we act as an AI researcher, but generate your output as a kind of bullet points. And for the second one, we ask to generate as a financial advisor but generated. You can see that financial advisor talking about financial data, new articles, etc., while the other one mostly talking about the computational efficiency and larger counterpart, etc., and then less memory and computational resources. So the language it changed a little bit. So that's pretty much, you could play a little bit around that and see that what type of a persona you would be able by changing different persona in a system, you would be able to get what type of output. However, we would like to, after that, we would like to maybe have a kind of conversation with the models. So we need to keep the conversation and save it somewhere to be able to reuse it over time, over the time. So to do so, what we need to do here is that is simply create a different list and keep the history of a conversation. You could see that for a message, the first turn would just say that, well, you're a helpful assistant. What is language models? And then for the second one, you might ask, you might ask, can you give me a real examples? And then at the end, you could say that, well, why small language models matter. So every run where we do, we need to pass it through the chat function that we defined on top, and then we append it in order to be able to keep the history. And then for turn 2, we exactly do the same thing, and we give it to the models, the appended the chat templates to the models, and then we repeat this process 2-3 times. And we see that what would be the output look like. In that way, you would be able to keep the history of a conversation, and you would be able to hold the conversation with that. Obviously, this method is not an optimal method, but it just for the sake of seeing how the language, what you could do with chat template, I think is quite useful. So what is language model? Is a type of artificial intelligence designed to process, analyze, and generate a human-like language. Can you give me a real-world example? It just says that, well, a well-known example of language model is Siri, virtual assistant developed by Apple. And then why is a small better than better in some cases? In language model, a smaller model can be better because they are more efficient to train, for example. So you could see that we are able to run that model by having kind of conversation. So you could also play a little bit with the different parameters. In the tutorial 1, as I mentioned, we explained about the temperature, top P, top K. You would be able to get kind of, let's say, generate your output in a conservative way, or in more innovative way, by playing a little bit with these parameters. So by this, we reached to the end of our second lab. I think we have learned a lot of cool stuff. As a kind of exercise, I provide you a couple of exercises which is tailored with this lab here. I strongly recommend you to play a little bit around with that and come up with your idea around language models. In summary, what we have been covered in this lab is about seeing the limitation of a raw prompt. We learn about chat templates. We learn how to define the role like a system, user, and assistants. We learn about the apply chat template. We learn about add generated prompt in order to send the signal to the model that now is your turn to talk. We learn how to hold the conversation history. And at the end, we also learn how to play a little bit with the parameters like a temperature, top P and top K to be able to get the output, different output. So as a next step, what I would like to do is that we dive on the fine-tuning on the small language models based on the knowledge that you learn in the lab 1 and lab 2, because you might have your own data and you wanted to basically train the model such that it tailors specifically to your data and your needs. So I'm looking forward to meeting you in the next lab and do something exciting with you. Thank you very much, and see you in the next lab.